department, and today we are going to see about A-star search algorithm. And what is A-star search? Like it is the best techniques to find the shortest path. For example, if we are given a binary tree and we are asked to find the goal state with the shortest path, then we have to use A-star search to find the shortest path. And it was discovered by Peter Hart, Nils Nilsson, and Bertram Raphael of Stanford University, and it is used in various games and web-based maps, and it is termed as the best first search algorithm thus far. And for a star search algorithm, there is a formula which is f of n is equal to g of n plus h of n, where g of n is the actual cost of the path and h of n is the heuristic cost. And its algorithm is, it basically contains a list which is open and closed. When we open a list, it would be go into the open list, and when we close it, it would go to the closed list. And we should start with the source node, and we have to see its descendants, and we have to calculate the f of n for both of the descendants, and we have to find which is smaller from both the descendants, and we have to again select those smaller descendant, and we have to see for their descendant. And the next one is we have to do a problem. So this is a graph for a star search algorithm, and when the goal state and the source were not defined, we have to choose it wisely. And the starting node is a, so we have to choose the source as a, and the ending node is j. Why I'm saying j is that j don't have any heuristic value. The heuristic value of j is 0, so we are choosing j as a goal state. And we have to solve this. For example, we have to start from the source, that is a, and look at the descendants of a. A is b and f, so we have to calculate f of b and f of f. So when I calculate f of b, I'm getting 14, and when I calculate f of f, I'm getting 19. So from this both the equation, I can able to conclude that f is smaller than b. So the path would be a to f, and since f is smaller, I have to look the descendant of f, right? So f has g and h, so I have to calculate again f of g and f of h. So when I calculate it, I'm getting f of g as 9 and f of h is 13. Since f of g is smaller, I have to take f of g's descendants, and the path now would be a to f to g. So the descendants of g would be I only. So when I calculate the f of I, I'm getting 8. So the path would be a, f, g, and I. So I'm looking the descendants of I now. The descendants of I are e, j, and h. So I have to calculate f of e, f of j, and f of h. So f of g, f of j, f of e, and f of h. F of j would be 10, and f of e would be 15, and f of h would be 12. Since j is smaller, it goes towards j. So the path would be a to f to g to I to j. So this is the shortest path, and we can able to calculate the actual cost that the path taken is 10. So this is the graph. I have determined this path in a red line. A to f, it costs 3, and f to g it costs 1, and g to I it costs 3, and I to j it costs 3. So the total cost would be 10. And A-star search is used in various applications nowadays. The first application is navigation system and robotics, and then game development. In navigation system, we are using Google Maps, right? It shows the shortest path, even though the location has different ways to reach. It shows the shortest path first, so it gives a preference to the shortest path. Hence, A-star search is used in those navigation system. And in robotics, it helps robots to determine the obstacles in it, and it goes away from the obstacles and won't hit by the obstacles there. Next, game development. We all play games, right? There would be NPCs, which is non-playable character. It will just roam around in the city without hitting the buildings and blocks there, without disturbing our game. So for that, A-star search is used in those NPCs to move and away without disturbing our gameplay experience. And the next one is conclusion. Thus far, we have seen various application inclusion formulas in how to include it in algorithm of A-star search. Thus far, it is used in various application in our day-to-day world. So that's it about my presentation. Thank you.